Good morning, everyone. My name is Yusheng Huang from Guangdong Polytechnic Normal University. Today, I am excited to present Affective-CoT, our framework for decomposing multimodal emotion reasoning. This is not just a research presentation. It is also the winner's solution for the MER 2025 Descriptive Emotion Understanding Challenge. Here's a quick look at our agenda for today. The presentation is divided into two main parts. First, in section 1, I will walk you through our solution, Affective-CoT. I'll explain the core ideas, the framework's architecture, and the key strategies that led us to win the competition. Then, in section 2, I'd like to take this opportunity as a participant and winner to share some thoughts and offer a constructive outlook for the future of the DES track, proposing some ways we might collectively enhance its evaluation framework. Let's begin by addressing the core challenge we aim to solve, moving from ambiguous, often conflicting cues to trustworthy, interpretable insights. The problem is that, in the real world, multimodal inputs, what we see, what we hear, what we read, are often not in perfect alignment. This presents a dilemma. On one hand, we have these powerful but opaque black box models. They give us an answer, but not the reasoning. This lack of transparency limits trust and makes it nearly impossible to analyze failures. On the other hand, for any high-stakes application, understanding the why is just as critical as knowing the what. So, our philosophy was simple. Don't just build a bigger black box. Decompose the reasoning process to emulate how human experts analyze complex emotions. This slide illustrates our core idea, a shift from a single, opaque mind to a hierarchical cognitive workflow. The traditional approach, shown at the top, treats emotion understanding as a single step. A video goes in and a description comes out of a monolithic MLLM. It's simple, but it's a black box. Our approach, Affective-CoT, employ expert models for perception to extract structured evidence. This evidence is then fed into a central reasoning module, which thinks step by step to produce a final grounded description. We won first place in the MER 2025 DS track. So, how does Affective-CoT actually work? Let's look at the framework overview. It begins with stage 1, decoupled perception, which we call the eyes and ears. Here, specialized models like Qwen2 5VL for vision and Qwen2 audio for audio act as domain experts. They don't jump to conclusions. Their sole job is to convert raw video and audio into structured semantic evidence in a JSON format. This evidence then flows into stage 2, the cognitive workflow, or the brain. A central reasoning LLM, in our case DeepSeek R1, takes over. It executes a rule-based process to integrate evidence from all modalities, analyze consistency to check for conflicts, and resolve conflicts based on a set of predefined heuristics, such as prioritizing verbal content. Finally, in stage 3, descriptive synthesis, the final description is generated based on the entire reasoning trace, ensuring that every claim is coherent, faithful, and explicitly grounded in the evidence gathered in stage 1. Let's look at a couple of case studies to see this in action. In the top example, we see a classic case of multimodal conflict, what we call a pained smile. The subject's nonverbal cues clearly project sadness and weariness. However, her subtitled words, "I can handle it myself," communicate firm resolve. Our framework explicitly identifies this conflict and defines the core emotional state as one of pained but resolute determination. In the second example, our model captures a dynamic emotional pivot. The subject begins in a state of personal despair, but his expression and tone shift to one of empathetic encouragement for someone else. Affective-CoT successfully deconstructs this sequence, resulting in a layered description of resigned despair for himself, coupled with emergent empathy for another. To understand why our strategy was so effective, it's crucial to understand how success is measured in this competition. The old way of comparing a model's output to a single ground truth description is flawed because it's too rigid. The modern approach, as highlighted in works like Prefer and used in the MER 2025 competition, is pairwise preference. Human evaluators are shown the same video and two different descriptions, and they simply choose which one is better. The key takeaway is this: to win, your output doesn't just need to be correct. It needs to be preferred by humans. It must be more insightful, nuanced, and well-written. This philosophy was absolutely central to our strategy. So, our first winning edge was a deep focus on aligning with human preference. Our insight was simple. If we are being judged by human experts, our model needs to learn what a good description looks and feels like to a human expert. Our strategy was to learn from the best. We used a powerful closed-source model, Gemini 2.5 Pro, to generate a small set of highly nuanced, human-like descriptions. These gold standard examples were then used as few-shot prompts to guide our Affective-CoT model. The result is clear. The standard zero-shot output is good, but the output aligned with human preference is far more insightful, detailed, and analytical, capturing the deep sadness and resigned awareness that a human expert would identify. Our second winning edge was about preserving linguistic integrity, especially with multilingual content. The insight here is that direct machine translation of subtitles, for example from Chinese to English, often loses crucial emotional nuance and cultural context. A human evaluator would easily spot this. Our strategy was to see the full picture. Our reasoning LLM was given access to both the original Chinese subtitle and its English translation. The result was a richer, more authentic context, leading to more accurate reasoning that a human judge would find more faithful and convincing. In summary, the combination of our Affective-CoT framework and these two key strategic choices, aligning with human preference and preserving linguistic integrity, led us to be awarded first place in the official human evaluation of the DES track. The selection of our winning components was critical. For perception, Qwen 2 5VL and Qwen 2 Audio proved to be the most accurate and well-structured evidence extractors. And for reasoning, DeepSeek R1 was superior in its ability to follow our complex cognitive workflow and produce logical, faithful reasoning traces, especially when dealing with contradictory cues. To conclude the first part of my talk, we won the Me R2025DS challenge by proposing Affective-CoT. Our victory was not based on a single model, but on a holistic system and strategy that included a robust framework, careful model selection, and a deep focus on human preferences. Of course, our work has limitations, including the inherent subjectivity of evaluation and the high computational cost. For future work, we plan to enhance efficiency and generalize the framework. But most importantly, and this serves as a transition to my next section, we believe it is crucial for the community to develop better metrics. And that last point is what I'd like to spend the final part of my talk on. As participants, we have a deep appreciation for this challenge, and we'd like to offer some constructive thoughts. The DES track has immense pioneering value, but it also faces challenges: the pure subjectivity of evaluation and the lack of instant feedback for participants. This leads to our goal. Can we design an evaluation system that is objective, diagnostic, and efficient, while preserving the track's core values? Our first suggestion is to implement an automated and reference-free evaluation pipeline. The core idea is that we must evaluate a description's intrinsic quality, not its similarity to a single golden answer. This means assessing two key things. First, how well does it match the video? And second, how well does it articulate emotion? As shown in this diagram, a participant's submission would automatically be evaluated across 3 objective dimensions, powering a live leaderboard that provides valuable diagnostic scores. Let's break down these objective metrics. First, cross-model consistency, measured by CLIP score. Using a fixed pre-trained model, this provides a standard, reproducible score for how well the text holistically matches the visual content. Second, emotional lexicon validity, measured by a lexicon score. Using a fixed public lexicon like NRC, we can objectively quantify the richness and diversity of emotional language used in the description, without needing any reference text. And third, a supplemental metric for factual grounding, which cleverly uses per score against a factual base. The idea is simple. The organizers first use a fixed captioning model to generate a simple objective fact sheet for each video. Then, we can calculate the per score between a participant's description and this fact sheet. This ensures the description is grounded in the objective reality of the video and penalizes hallucinations. Together, these 3 metrics can be weighted to form a single, robust, objective score for a live leaderboard. Objective metrics are great, but human judgment remains the gold standard. Our second suggestion is to enhance it by making it a lightweight diagnostic process. The core idea is to move from a single, which is better, choice to a multi-dimensional comparison. As you can see in the interface mockup, annotators would make comparative judgments on dimensions like emotional accuracy and analytical depth. This is faster for them and provides us with much richer diagnostic data. Furthermore, to make this more scalable and robust, we propose complementing human evaluation with an LLM as a judge score. Here, a jury of 3 diverse, powerful LLMs performs the same pairwise comparison, with the final decision based on a majority vote. This is a state-of-the-art practice, validated by benchmarks like MT-Bench. The final subjective score would then be a weighted sum of the human and LLM panel scores. That brings me to the end of my presentation. With our Affective-CoT framework, we have demonstrated a new path for transparent and robust emotion reasoning. And with these suggestions for a hybrid evaluation framework, we hope to contribute to the continued success and evolution of this fantastic challenge. Thank you very much for your attention. The QR codes here link to our full paper and my contact information. I will now be happy to answer any questions you may have.